Oftentimes in Tableau, a level of detail and aggregation can work together in really counterintuitive ways when we're performing more complicated calculations. And it's one of the more difficult parts of Tableau, to be perfectly honest, this notion of level of detail calculations. So we're going to be dealing with this in a lot more detail in a future week. But for now, I at least wanted to hint or show, I guess, not so much of a hint, but show that this can be an issue if we're not very, very careful. So let's do an example from economics. So the most common way, or a common way, to talk about economic productivity is GDP per capita. So this is the GDP per person. And this allows us to compare directly between big countries and small countries. Like if we were just comparing GDPs by themselves, big countries would have bigger GDPs, small countries would have smaller GDPs, but not because one of the countries is more productive than the other, just because it's larger than the other. So by dividing by the total population, you're trying to control for population size. So imagine we wanted to look at the GDP per capita for a region, for not just a country, but a region. The right way to think about that is the total economic output of that region, the sum of all the GDPs of the individual countries, divided by the sum of all the populations. So this really is the total economic output per population total. And so this is the sum of the GDPs divided by the sum of the populations. Notice that this is not the same as summing the individual GDPs per capita. So for instance, if country A produces $2 per person and country B produces $2 per person, then it's not the case that taken together they produce $4 per person, right? That doesn't make any sense. So we can't just sum the individual GDPs, but we also can't take the average of the individual GDP per capita either. The reason for this is a little bit more nuanced. So imagine country A produces $2 per person and country B produces $4 per person. It's not the case that together they produce $3 per person, and that part can be counterintuitive. The issue here is the size of the countries. So imagine country A, the lower producing country, is much, much, much bigger, and country B, the higher producing country, is much, much, much smaller. Like in relation to country A, country B doesn't really matter. It's not gonna add much to the overall economic output of the region. Country A is going to dominate. So we'll be much closer to $2 per person on average than we are to $3 per person. So the point here is mathematically, taking the ratio of the sums, so summing GDP and dividing by the population sum is not the same as summing the fractions, and it's not the same thing as averaging the fractions. And this is just true in general. Be very, very careful in general, adding fractions or averaging fractions, or averaging averages, for instance. Nothing good comes from this. And in particular, Tableau will reliably screw this up. Like, if there's one thing I know about level of detail calculations or level of detail in Tableau in general, it's be very, very, very careful to specify exactly what you mean. In fact, there are times when I'll be doing a calculation and the default Tableau way, and it's like, no. I'm going to do it by hand. But because I know it will work. I know it will work exactly the way I need it to, and I can't trust Tableau all the time. So we're going to develop the tools to allow you to do these things. So let's dive into Tableau. We're going to do things incorrectly, and then we're going to do things correctly. So let's define the GDP per capita incorrectly first, and then we'll do it correctly next. So let's create a calculated field, and we'll call this GDP per capita incorrect. Okay, the incorrect way to do this is just GDP per population total. Now, first of all, remember that variables in Tableau are enclosed in square brackets, and you know it's work because it's turned orange. And then the second thing is, notice how freaking natural this is, right? Like, it's so natural to do it this way. You just say the GDP per capita is the GDP divided by the people, right? It's so frustrating that it doesn't work this way, but it doesn't work this way for a good reason. And we're going to talk about this in a moment. So let's go ahead like this, and we'll go to region, drag it over to rows like we did earlier, and then we'll drag GDP per capita incorrect up to our text here. Now, notice that the default aggregation is sum. This one is one of the ones that we said didn't make sense. Let's just change it to average to make it a little bit closer. So what is this saying? Here's what happens. The GDP per capita is computed for each row in the data set. Okay, so for each row in the data set, it goes through. In fact, we can look at this. Let's go ahead and look at Africa. And if we scroll over to GDP per capita incorrect, this is the GDP in billions. I'm sorry, this is the GDP divided by the population for Algeria in year 2000. And then it does the same thing for Angola in year 2000, the same thing for Benin in year 2000, Botswana, so on and so on and so on. It calculates, where did it go? It calculates the GDP per capita incorrect for each one of these country years. Each one of these country years gets its own value of GDP per capita incorrect. Then we aggregate. After each one of these is computed, then we aggregate by taking the average of this entire column. Here's where the problem comes in. Some of these African countries are quite large in terms of population and GDP. Some of them are quite small in terms of population or GDP. But because we've already computed this GDP per capita, those differences are completely erased. Like, we no longer have any sense of which countries are bigger or smaller, or which countries have higher or lower GDPs. We're just looking at the GDP per capita. And so this completely throws off our computation, in the same way that, like, having country A with $2 per person and 1 billion people, and country B with $4 per person and 1 million people, the same way that particular situation threw off our computation, we're having the same issue right here. We can't compute the GDP per capita first and then take the average. That's the problem. We can't take the average of the fractions. So how do we do this right then? Like, what does that look like? Well, let's define it. So we'll do create calculated field, GDP per capita. We'll call this one correct. The way to do this correctly is by saying the sum of the GDP divided by the sum of the population total. So what's going to happen here? When we do this, what's going to happen? Notice what happens. Notice what happens. What happens? What is it? Too many what happens is. So here's what goes on. Tableau applies the sum function at the level of detail of the table or the visualization. So if I drag this to text here, what's happening with this number 1300, the bottom one, which is the correct number, is that we go through, oops, I'm trying to show you the thing again. For each one of the regions listed here, we go through and we calculate the sum of the GDP in the region, and we calculate the sum of the population in the region, and then we take the average. Then we take that average out. I'm sorry, we don't even have to take the average. We just take the sum of the region's GDP and divide it by the sum of the region's population, and we're good to go. We don't have to take any kind of average because that number is already boiled down as much as it needs to be, as much as it can be, which is why we've gone this aggregation was average here, but it's ag here. Ag means you can't even aggregate it. It's already boiled down to just a single number and there's nothing else to do. So again, the point here is that when we say sum here, when we say sum here, it is summing at whatever the level of detail of the view is. So right now, the level of the detail of the view is region. So it says, okay, I'm going to sum GDP by region, and then I'm going to divide that by the sum by region of total population. So the sum of the population across the entire region is my denominator, and the sum of the GDP across the entire region is my numerator. Now notice that this flexes beautifully if I change this, if I drag country region, for instance, into rows. So now what's happening is that when I take the sum in the correct version, just look at it again. Sometimes it helps me just look at it. So the sum here now is saying, okay, I'm going to sum over whatever the level of detail of the view is. And so I'm going to say for Algeria, I'm going to sum the GDP for all of Algeria, and then I'm going to sum the population for Algeria, and then everything's good. And notice that these numbers were quite far apart earlier, but now they're quite close. And if I drag in year, they're identical. And this is, if you can understand this part, you've understood it perfectly, because at this point, both of these things just have one data point that's used to calculate them. So both for the incorrect version and for the correct version, there's only one row that's being used. So whether you sum and then take the average, I'm sorry, whether you compute the ratio and then take the average, or whether you sum and then take the ratio, you get the same result because there's just one row in here. There's just one thing going on. But the more and more constituents I have, the farther and farther these two numbers get apart, because the worse and worse my mathematical error is becoming. Like, it's getting bigger and bigger. And if I go all the way up to region, for instance, these numbers can be really, really far off, like 20, 30, 40% off from one another. Because again, some countries are very big or very productive. Some countries are very small or very unproductive. But when I take the ratio first and get GDP per capita and then take the average, as I did in the incorrect version, I'm treating all of those countries as the same. I'm disregarding their population size. I'm disregarding their GDP size. I'm just looking at the average of those ratios, those per capita ratios. Whereas if I instead sum the population and sum the GDP and then look at the ratio across the whole region, I get a much more accurate measure of productivity. So my guess is it's still not quite clear. We need to practice this thing. We need to see it go wrong and really get our heads around what's going on. But the big idea is anytime you are calculating a ratio or the value of any kind of more complicated function, we need to be really, really careful about using level of detail correctly. And typically speaking, the right way to think about it in most cases is to wait as long as possible to define these functions. So you don't want to be defining the ratio first and then taking the average of the ratio. You want to be summing this and then summing that and then taking the ratio so that Tableau correctly computes the level of detail as it goes through.